They say if you join the Navy, you'll see the world, but if you join a space fleet, you might see several. Of course, what you'll mostly see is an awful lot of nothing. Space is big, really big. Just beyond immense and enormously huge. It contains everything there is, and yet what it mostly contains is an awful lot of nothing whatsoever. This can make it a bit difficult to visualize properly, and also means that spaceships fighting each other in the void can be tricky to show in an exciting and realistic way. Indeed, while modern CGI lets even lower budget TV shows display thousands of ships fighting at once, not just one or two plastic models, we still have the challenge that even the best CGI can't really help with, and that's how empty and unexciting actual space is compared to the World War era battleship engagements or airplane dogfights we tend to use as a basis for naval conflicts in space. And that's a good place to begin our discussion of space combat and battlefleets, our habit of viewing everything as naval analogies. Space is not an ocean. I love those science fiction tales that portray it that way. I love the poetry of thinking of it as the ocean of the night, and I use it myself a lot, but it's just not true. Even the more three-dimensional perspectives of contemplating spaceships as submarines instead of battle cruisers or aircraft carriers is wrong, though they get it better in terms of the 3D aspect and the very slow timelines of combat, or very fast timelines. One of our key notions today is that it looks like space combat will involve a lot of actions taking place in the blink of an eye, and a lot taking months if not years or even decades to run their course. Indeed, wars between two relatively small interstellar empires of just a few thousand star systems, each just a dot on the galactic map, might take 1,000 years just to see the battle lines get fully drawn up and fortified. While that emptiness of space tends to exaggerate the value of laser and beam weapons, they have a role in space combat, and their sheer speed and lethality means engagements at ranges of even hundreds of miles can potentially resolve in mere milliseconds. Missiles and projectiles can also move very fast in space, and have internal guidance so they can change directions to reach where a ship has moved to since you saw it and fired, which can be a long way with fast ships in space. They also don't have to fight air drag or gravity to keep going in a mostly straight line indefinitely, like projectiles or missiles on Earth do, while a laser beam will diffuse with distance. Now, it isn't accurate to say there's no friction or drag in space. It isn't completely empty. There are storms in space and places that are much thicker than others, but by and large these analogies don't translate well into space and often would only in very specific cases. You cannot hide in a nebula, but you can hide inside bigger stars, or maybe a planetary nebula. Also, modern ships don't sail anymore, and solar sails aren't really very analogous for spaceships. There's no propellers because there's nothing to propel you through. The closest analogy there might be a Bussard ram scoop drive. You don't need to veer and dodge around an asteroid belt, but you really do need to worry about ramming into things passing through one at very high speeds. You don't park your ship next to someone else and shoot at each other, though as we'll see today, a lot depends on technology and minor variations can change things a lot. So we can't tell you how space armadas are going to look, because even if I had a crystal ball to see one in the future, it will change a lot over time as technology and experience grows. That's already true nowadays, as we've seen combat and strategy constantly change and adapt throughout our history with changes in technology. The rules of warfare are constantly changing, and this is part of the reason for our standing joke on the channel on that topic. If you didn't know, I used to be in the US Army from 2003 to 2010 and am a veteran, having served a little over a year in combat zones throughout various places in Iraq. I also worked briefly as a civilian researcher for the Air Force before that in my late teens, and I'm from a military family. And I had the honor of guest lecturing at the Air Force Academy a few years back. I'm actually writing this right after Memorial Day, so that service is on my mind. So is the space conference I attended right before that, where a lot of the attendees were astronauts or fighter pilots, and also where we gave Captain Kirk the Heinlein Award. And I think Robert Heinlein helped put a lot of realism into military-themed science fiction with his work. particularly the concept of high-tech heavy infantry like we see introduced in Starship Troopers, the book, not the utterly unrelated film of the same name. This is a little ironic since he was in the Navy, not the Army or Marines, but I suppose it means I can talk space navies even if I was in the Army, not the Marines. And again, while we'll be focused on large fleets and their composition today, it's not truly very Navy related because space is not an ocean, but we'll still use a lot of the terminology as familiar and also ask if some of their space-based equivalents like battleships or carriers or even the basic rank structure would fit. I do usually bring up my time in the Army and military-related episodes for the same reason I mentioned I'm the president of the National Space Society during space episodes or mention that my degree is in physics. People sometimes wonder who the heck this guy with the strange voice is, and also wonder if he knows what the heck he's talking about. So every so often it helps to mention those backgrounds in an episode to clarify that you do know what you're talking about. Except that I don't know what I'm talking about. I was a ground pounder in artillery who also did a lot of light infantry and motorized rifle company time. I never served on a ship. I did work for the Air Force as a civilian for a time, but the only planes I've ever flown are a Piper Cherokee and a Cessna, not some fighter jet. In fairness, neither a fighter pilot, a battleship commander, or a submariner knows much about space warfare either, since it hasn't happened yet. And in truth, no one really knows much about how the next war, even here on Earth, is going to unfold or look like, because it hasn't happened yet either. And they always tend to be surprising, in large part because any good strategist will try to do the unexpected, and because an awful lot of wars only happen because one side or another horribly overestimated themselves or underestimated their enemy. You have to take risks and go for surprises to win in war. At the same time, risk-taking and gambling is a bad idea in strategy and tends to fail when following sound doctrine often works better. One of the comments I got from a mentor that always resonated with me in terms of treating wars like grand strategy games run by chess masters and geniuses was that you should never assume they were that brilliant, since they were either dumb enough to have started a war in the first place, or alternatively, got attacked because they made themselves look an inviting prospect for aggression. I got a lot of advice from various mentors in the military, and it seemed like virtually all of my sergeants had some rule or key principle they thought was the most important thing, but not the same as the one my other sergeants had, or sometimes even the same sergeant but on a different day. I started making notes on them to pass on when I became a sergeant myself a little over 2 years into my service, and added more afterward because the worst vice is advice, and my fellow sergeants kept giving me plenty, which was good because I still needed plenty of it. But those became the basis for the show's joke on the first rule of warfare, which began way back in our episode Space Warfare and has been a running gag ever since then, and the show turns 10 years old next week. But at the same time, it also isn't a joke. Every rule of warfare is the first rule of warfare, because forgetting any of them might be the last mistake you ever make. For those who have been watching the video version, you've been seeing a bunch of those running on the screen. For audio-only listeners, there's collections of them on our Facebook and Reddit forums. Just Google my name and the first rule of warfare and they'll pop up, along with plenty of other good discussions, as there's a lot of veterans and historians in the audience. And we do have those forums linked on the descriptions of all of our episodes, right under those like and subscribe buttons. As we get into our discussion, it's important to note that warfare is obviously a very serious discussion topic, but we'll be treating it more with humor today as we do in other episodes, even if it is dark humor at times. Sometimes jokes about war land with all the grace of an orbital bombardment, so let's all remember what Joseph Stalin said, that dark humor is like food. Not everyone gets it. Another critical thing to emphasize from the outset is that the future of warfare is not everything being done by AI, and partially that's because the term artificial intelligence is almost completely meaningless in a futuristic context. A recurring point on this show is that since artificial usually implies man-made, humans are already about as artificial as it gets. Decades are spent raising and training the typical human mind, and this will likely only grow more artificial in time. We have cybernetic and mind augmentation to consider, or a brain in a jar implanted in the armored vault of a war machine, and an uploaded copy of a human mind on a computer is presumably just as fast as a classic science fiction computer intellect, robot mind, or android. All of which would, in practice, be too slow for frontline work, Conscious minds are too smart to be fast, and future battlefield hierarchies are more likely to resemble ecosystems than pyramids. No matter how good your AI is, if your enemy has parallel computer chip technology, it's going to win virtually every equivalent to a Wild West duel or dogfight exactly because it's stupid. This doesn't mean a stupid person wins a gunfight with a smart one. It means fast reflexes and instincts are typically what's key. Emphasis on typically, and any effort for higher thought will slow that down. If your program for deciding to dodge or shoot requires 10 mental steps and they require 9, or they get their step done in 9 milliseconds and you took 10, then they shot first, just like Han Solo. And if your engagement range is 30 meters with laser pistols, their shot only took 100 nanoseconds to hit you. So at time 0 you both start cogitating how to act. At 9 milliseconds or 9 million nanoseconds, they decide to fire, and at 9.000001 milliseconds, their laser blast hits you and vaporizes you before you would have fired 999,900 nanoseconds later. This matters though because engagement times are the most critical aspect of space warfare, and they depend on how far apart you are, how fast your weapon moves, and how much time is being spent to acquire a target, decide to shoot it, and actually aim and fire the weapon. Bullets take time to move, something you really notice in artillery where shells can take the better part of a minute to arrive on target, but it's basically instant at pistol range like in Wild West duels, at least in human reaction timelines. I do remember when I was still fairly new with rifles, sometimes thinking I'd missed at longer ranges where it can take a quarter or half a second to hear that ping off a metal target, as the sound has to travel back even slower than the bullet moved, and I'd try to adjust my aim only to realize I was fine. That translates into space combat where even if you are using some magic weapon that can travel faster than light to strike a ship a million miles away, you still have 5 seconds after that weapon hits before you see it and know if you need to shoot again or hit and need to pick a new target. There's also the aspect that while there is no sound in space, there are still shockwaves and debris. And if you're trying to tear through some ship that's got meters thick armor on it, you may have to wait several more seconds for all that debris cloud to disperse enough to see if you hit. And during that time, any laser beam you're shooting through that cloud of debris is getting scattered by that debris, and any high velocity munition you fired through it is blowing up from striking that debris. So are any fighter craft or drones who are trying to race around really close to that ship to avoid the equivalent of anti-aircraft guns, usually called point defense turrets in this context. Lasers and other beams also aren't thin cylinders all the way out to infinity. They begin spreading out into a cone when they leave the weapon that fired them, long before they hit any debris around their target. They are amazing for close-in defense, where they basically cannot miss. Their offensive role is a little more dubious, even at close range, though we have a lot of in-between cases like a bomb-pumped laser, which can get closer to an enemy ship and target more real-time to explode to fire a powerful laser blast. See Project Excalibur. Lasers aren't a cure-all for close-in defense either. They don't carry much momentum for their energy level, so they're frying systems, burning out sensors and guidance, and potentially vaporizing small objects, or shoving something aside by ablating part of its surface. But even a vaporized object, or its relativistic remnant cloud, is still barreling toward your ship at huge velocities. Now it's more like a shotgun blast at least. But projectiles are all about concentrated hammering, even when spread out to something as small as your hand to absorb the recoil of a pistol, which is identical to the bullet's momentum. You're fairly safe from damage. You're also probably moving at least many tens of miles or kilometers a second relative to your enemy, if not tens or hundreds of times faster, so any broadside fire you had as you passed by was one short window followed by a long period of course changes and repairs. As such, engagements between two big ships blowing past each other are generally going to be either totally fatal or inconclusive. David Webber's military sci-fi series, focused around the naval officer Honor Harrington, explores a lot of 3D and relativistic space combat, and does the scale very well, including light lag on weapons and fleet tactics, which generally do involve running toward each other a lot. You wouldn't be running toward each other unless you felt you either were going to probably win, or felt that you could survive one charge and pass by and escape while they had to turn around. which might take them entire days even with powerful engines. If you survive that pass, you got tons of times to assess your damage, their damage, and what their weapon's capability really was, as you might not have known till then, and they didn't have much reason to hold back and take it on the chin. So if you lost that first pass, you aren't wasting fuel swinging back around for another. You are pouring on your speed in your existing direction and hoping that they don't have enough fuel to halt their speed in their direction, turn, match your previous speed, and then catch up to you. This stuff only happens in science fiction where your fuel supplies never seem to run out. Ironically, one of the few times I remember it happening during a chase was in The Last Jedi, which somehow still managed to botch all the scientific realism of that scenario even before that hyperspace ship ramming, which is about accurate for insanely destructive collision damage at least, just terminally screwed with the canon of the setting. We can contemplate technologies that might make such near-infinite fuel supplies available, but the reason it works in air or sea is because you constantly burn fuel to move, and the faster you move, the more fuel you have to burn to fight the drag of air or sea, so often someone really can't afford to pivot and catch up to you, especially if your battle damage is slowing you, either from a loss of engine power or extra drag forces from all the non-aerodynamic bullet holes in your ship or plane. People also tend to forget about that when thinking about small spaceships run by AI that can react ultra fast and dodge left and right while accelerating at hundreds of Gs, jinking around to dodge fire. This is the most critical point of space warfare, because we think of big ships as slower than small ones, which is probably wrong in most cases. Bigger will be faster in terms of top cruising speed. We also tend to assume the small craft can react and dodge better, which they can, but only while they have fuel, or possibly propellant and an energy beam or wire from some mothership. Otherwise, they're going to run out of fuel real fast, especially as the rule of thumb is the faster you want to be able to accelerate, the less efficient your engine is. This is 3 reasons why we start seeing the value of battlefleets over one single ship, and a diversity of ship types and roles. First, very rarely will 2 ships go charge right toward each other, and when they do, it will generally be inconclusive, but that dynamic shifts heavily in fleet engagements where damaged ships have a reason to remain and fight and even be destroyed, while at the same time, you are very unlikely to have 2 fleets just form up in a pack and charge each other at maximum speed for a pass. Otherwise, you might see a lot of small ships ramming the bigger capital ships. Second, you have a lot of debris and smaller craft involved in such actions, and generally the damage a random piece of junk does to you in a collision rises with its mass and with the square of its velocity, meaning a fragment a millionth the size of your ship might utterly wreck that ship at speeds we normally think of as even on the low side of interstellar speeds. So you do have motivation to engage slower or further away with longer range weapons, since otherwise the debris of the ships you killed might trash you even in situations where the scope of martial difference was a modern aircraft carrier fleet against a few canoes. This means you get longer engagement windows, which means you do have more time for thought. Even your head-on charges might be less like a cavalry joust and instead pass no closer than thousands of miles apart. Third, your giant carrier ship can probably move at much higher speeds to get to combat zones or patrol around, but it is a huge target and slow to dodge or react, so it tends to make sense for it to send much smaller craft out that are fully fueled up and which can be refueled from bigger ships afterwards. And this is unlikely to be just 2 sizes, humongous carrier and tiny drone, but a whole range of vessels, maybe even carriers of carriers, along with many different types of ships for each scale too. Hence more of the ecosystem than pyramid style. And we tend to see this with professional militaries too, broadening ranges of specialization in role, training, and equipment. Let's discuss range some more. I don't need to use a laser pistol on the ground because the speed advantage over a bullet is negligible compared to human reaction times, and real mechanical ones too. People don't think about it much, but there is a real time spent between when you pull a trigger and when that force moves through the spring. This is not instant. Even when you push down on a lever or poke something with a stick, Time passes from when one end starts moving and the other reflects that. It is a very long time compared to how fast light moves down that stick. It is more or less the same time sound waves travel down it though. Even a turret rotating to fire can only move so fast without shredding itself under its own centrifugal force. Your hypothetical super-fast android might think real fast compared to a human, but it can only swing its arm and gun up so fast without ripping them off, even if it has the power in that limb to move that fast. At certain ranges, the flight time of the weapon, whether it's a light-speed beam of photons or a bullet or even a punch, can be minuscule compared to the time the decision or actions to enact them take, or that the damage itself takes to propagate. Generally, shockwaves in matter or heat move at around a millionth the speed of light, roughly the speed of sound. Even if you shot someone in the chest with a laser beam, it might take longer to radiate out to their hand or head than the time it took for their own slightly delayed action to occur. So you shot them at 9 milliseconds and they fired at 10, but it took more than a millisecond to vaporize them. You also might get killed by being that close to enough energy to vaporize someone, but more on that in a second. One problem with shooting down nukes is that the ICBM is moving faster than the shockwave of any explosive detonation next to it, so you have to hit it head on or just right enough ahead that your shrapnel can impact it before flying clear of its window. This is greatly exacerbated at higher speeds. 3 staples of science fiction are teleportation, vaporization, and force fields or shields. They mostly exist for the purpose of low special effects budgets because we can't just pause a camera and move someone in or out of the shot then resume, showing them being vaporized or teleporting there or away. In practice, you would never build a handheld weapon to vaporize a person because it's pointless overkill. Of course, that is the first rule of warfare. There is no such thing as overkill. But then again, the first rule of warfare is that you will always run out of ammunition at the worst possible time, which will arrive much quicker when wasting it by shooting something that's already dead or using an H-bomb when a fly swatter was sufficient. Note that this does not apply when fighting vampires or other undead opponents, even space vampires. The energy needed to vaporize someone is roughly 1,000,000 times the kinetic energy of a bullet, which means the same weapon could instead shoot 1,000,000 times, or be considerably lighter and permit either more useful gear for a person, like armor, or a lighter or faster drone carrying the weapon. It's the same for blowing up an entire planet. It's pretty silly as a waste of energy. Alternatively, the idea that you wouldn't invade and instead glass the planet from orbit is also a bit backwards, as losing 1,000,000 soldiers in an invasion, which might be robots remotely controlled anyway, might be considered more costly than the loss of time, energy, money, or even lives on rebuilding that planet you hammered into dust. One thing we should always assume high-tech civilizations have is the ability to do math and make actuarial tables. Another thing a high-tech civilization is always going to have is a huge amount of industry and orbital infrastructure near its developed planets, including military infrastructure. So as we saw in orbital defense platforms last year, no sane fleet commander is going to just park in orbit around a planet on day one, because all those glorious mile-long battleships with armor meters thick is going to get utterly trashed by those planetary defenses, which can afford individual guns miles long and bunkers with a mile of armor. We also shouldn't always assume it's a fleet versus a planet, when in practice there are probably several major planets in that system and thousands of minor planets and asteroid bases. I always remember this from Star Trek, where the Borg invade, fly by Mars and get engaged by the Martian defenses, which was just 3 little ships that get blown away without the Borg cube even slowing down. There's no real reason why you'd pass by Mars to get to Earth, and normally you would expect a lot more non-futile resistance passing by a fortified planet. The Borg cube then does go and park above Earth, which apparently has no fortifications. It's just the capital of a unified interstellar empire of dozens of spacefaring races, so who needs fortifications? What's more, some fleet might indeed be able to come park right in orbit because that planet might not have a unified government that fleet is at war with, It might be that the battle fleets of Ganymede have shown up to go to war with Denmark, and everybody else reminded them that space debris and weapons of mass destruction getting used by either side would result in everybody else dogpiling them. Now, in terms of size, there is no real limit on how big you might build your ships, any more than there is on how many you might deploy in one fleet. Bigger is better, and quantity has a quality all its own, but you have to pay the bills for building and maintaining that fleet, and as Heinlein liked to say, there ain't no such thing as a free lunch. The acronym for which, incidentally, is on the cannon barrel of the Heinlein Award we just gave William Shatner right before I wrote this. It is a very important concept in a spaceship, and that includes the crew, because while the captain might work for free, that crew probably wants pay and lunch. Now, for all purposes on the show, the word crude is usually used to mean something human or human smart with a personality, including the superhuman, which is why we'll often still use man for human flight in general. We could imagine an entire legion of shock troops made of androids, but it could as easily be made of 1,000 copies of various mind uploads of expert soldiers who were completely fine with their copies being killed. Unmanned, meaning totally automated, is almost pointless to distinguish, because we're going to cram a chip into anything we can get away with, which is probably at least any weapon thumb-sized or bigger. Every weapon in that scale or bigger is going to qualify as a smart weapon, at least to the degree they were when the term became common with smart bombs in the early 90s, which were pretty dumb. Making it smarter than the job requires isn't a good idea too, and it's worth noting that computer chips are not any more sturdy than human brains, and that the more intricate you make them, the more fragile they tend to be to things like radiation or G-forces. They need to be smart enough to do the job at their level and without remote control. As mentioned, giving them much more brains is also likely to slow them down, and starts to risk your weapons deciding they would like to not die. They do need enough brains to do the job though because of the light lag and enemy jamming, which is going to be very easy when they are closer to their target than their mothership. Though actual physical wires are an option and might be used for maneuvering too. Jinking around left and right can help you avoid being hit, but burns fuel fast, especially if you're doing it constantly before an enemy can fire so that your position is always randomly changing so as to avoid laser weapons. But if you and a partner are physically connected by a rod or tether, you can change your position a lot by winching that tether in or letting it wind out without burning fuel. We might imagine half a dozen thumb-sized drones all connected to one about twice as big, with a decent amount more brains and some extra energy or fuel to transfer around. They might get severed or the command module blown up and need to continue autonomously at that point in a reduced capacity, but they could dodge around a lot. Let's say the drone was 1 centimeter across though, and that it could move at up to 100 Gs, which is pushing it for an object that has any real complexity and sophistication, especially when doing it in multiple directions and repeatedly, though higher is probably possible. That means in 1 second it can be moving a full kilometer per second in some direction and have covered 500 meters, and in 2 seconds 2 whole kilometers. Which means if it is jinking around like that, besides running out of fuel very fast, then at just 1 light second away, some enemy wanting to target it can only know its current position down to 500 meters, and even assuming it can spot, decide to shoot, and target and fire instantly, any beam it shoots needs another second to get there. Which means our little centimeter-sized drone could be anywhere in a spherical target bubble of 2 kilometers in radius. This same would apply to any ship of that size, but you might be a lot more willing to fire randomly a ship a kilometer wide in that volume than something the size of your thumb in a volume the size of a city. It's also worth noting that a light second is most of the distance to the moon and around 25 times wider than Earth, so finding and targeting a thumb-sized drone at that distance is pretty dubious anyway, and running into it at near light speed would be like being hit by a nuke. We won't bother calculating what it would be for a big old capital ship like the Enterprise to ram something at near light speed, let alone at warp speed like it was going to do that Borg cube.
Captain.
Then it's over.
Mr. Crusher, ready a collision course with the Borg ship. You heard me, a collision course.
Which should theoretically be infinite, but is another reason why you want to be careful doing high-speed close-range passes with other ships, as even them just venting their garbage-out airlocks where you might hit a bottle cap might be lethal. Your odds of hitting a vehicle that's randomly jinking around go up with its cross-section, or the square of its own radius if we're thinking something spherical or cylindrical and moving toward us. It goes down with the square of distance too, for beam weapons or solid dumb slugs, so hitting a big kilometer-wide ship by random fire is 10 billion times more likely than our centimeter-wide drone at the same range, and drops off inverse square to its maximum acceleration too. So if that bigger ship could only do 1g of acceleration, it is literally 100 trillion times easier to hit with random fire than that drone at the same distance. Of course, all things being equal, by the cube square law, it would have a quadrillion times the mass, and a lot of that likely to be armor. And because your surface area other people can hit only rises with the square of your size, while your volume or mass rises with the cube, bigger ships can afford thicker armor relative to an identical ship that's just shrunk down, meaning they take a lot more killing. This tells us that you also want to have non-beam weapons, ones that have some guidance on them, and any drone can be killed by another drone ramming it, probably a smaller one with even less brains. Fleets also let you spread out, and while there's no perfect stealth in space, smaller ships running behind your bigger ones might be very hard to see and track well as they approach. Also, things get deadlier the closer you get. You definitely have a value for having smaller picket ships a ways out from your fleet for early detection, and depending on the size of your ships and fleet, you might even have smaller picket ships for your picket ships and vanguards for your vanguard. With this in mind, we start seeing layers of defenses that, again, probably are not standardized or typically hierarchical, but that we'll treat that way anyway for simplicity of discussion here. I am going to assume for the moment that our ship sizes range from 1 centimeter drones that cannot operate alone for long, which we'll call a drone, then assume we have increments at 10 centimeters, a meter, 10 meters, 100 meters, 1 kilometer, and 10 kilometer juggernauts. I'll just call these respectively the ensign for 10 centimeters, the lieutenant for a meter, the commander for 10 meters, the captain for 100 meters, the commodore for a kilometer, and the admiral for 10 kilometers. I just skipped all the enlisted ranks since a lot of sci-fi often seems to forget we exist or horribly confuse the roles associated. We could just easily include those too, or just have your layers being numerical, or alphabetical or alphanumerical if we need enough of them. We talked about stupidly huge military organization charts like 25-star generals and super grand admirals in our Cosmic Capitals episode, incidentally. Ship names in general are pretty arbitrary too, but we could go drone, picket, destroyer, cruiser, battleship, carrier, dreadnought, and so on. Our 7 levels are not simply size of ship, but size of brain too, and in this case of senior brain. Note at each step those ships weren't just 10 times longer but 1,000 times as massive. There would be no reason for them to seek to be less dense and thus bigger targets. So level 7 is literally a billion or a quintillion times more massive than the drone. It is important to understand that chess analogies for combat often tend to be bad ones, because in chess you know everything your opponent does and you have very limited options and pieces, making it calculable, ultimately like tic-tac-toe. But every new piece in these sorts of systems, every expansion in board size, makes such certainty exponentially harder and thus requires much more brains for certainty. You also have a very real fog of war in space, though one in this case that's less about a limited how far you can see in space, but rather how far back in time you're looking due to light lag. Your commander at each higher level needs to be able to issue orders along multiple timelines of possible actions for the layers below to act upon based upon their more current knowledge. The faster, closer, and dumber you go, the more explicit those orders need to be for each set of eventualities. The smarter, slower, and farther from conflict you get, the more uncertainty in the state of the current battlefield you are going to have. And this even translates up to not just the admiral of the fleet, but the larger guns or missile tubes programming in order for the munitions they are firing in terms of what to do when they arrive at the enemy fleet in an hour, or a month, and observe the situation and possibly deploy their own sub-munitions and give them orders. This ship might be crewed by lots of other folks, but even if it is a single AI, a commodore or admiral mind, it is likely to have sub-minds for the same reason we have lower levels of mind on smaller ships, and departments and divisions on modern ships, military units, and any large organization. In this case, these subminds don't need as much brains for most tasks, and they can move faster at those simpler or dedicated tasks. Your ship engineer brain needs no poetry or strategy or cryptographic skills for diagnosing the engine's issues. For instance, your drone or picket ship needs no advanced strategy. What it can't handle, it routes up to the next higher level. That takes time, and each of those layers will be further back from the front or high-speed engagements, and probably at whatever distance they can make themselves a less tempting target for their size. Smarter ships might head closer to the action and place themselves at risk, exactly to take advantage of the fast but dumb drones to try to deceive them. So this is not a hard and fast rule, but then nothing in war ever is. I should note that anywhere inside what we normally picture for spaceship battle engagement ranges, 10 or less miles or kilometers basically, even our 100G centimeter drone is an insta-kill for a laser and has no useful armor. So anything you're using inside this range should just be considered brain dead because it can't be missed by a laser or armored against a wide weak beam just sweeping the area with some equivalent to an EMP gun or a bright flashlight to saturate or burn out sensors. There is no dodging at this scale. Even pea-sized objects somehow able to pull 10,000 G maneuvers aren't getting much closer before they'd be vaporized. Even if we get generous with the decision and targeting reaction times by whatever simple submines on an enemy ship control its point defenses. Our ensign ship, a tenth of a meter wide, needs to be 100 times further back than the drones. That lieutenant vessel, just barely big enough to cram a human mind inside if we wanted, needs to be likewise further back. But if it really is 100 times wider than the drone, then it can carry 1,000,000 times the brains the drone has and armor that's 100 times thicker. All things being equal, which means the enemy needs to use much larger or more focused weapons on it. It can also afford a broader range of countermeasures in general. This keeps scaling up to get very big and slow to react vessels, but isn't necessarily particularly vulnerable at medium range to beams either, as the ship probably has a rotating exterior hull to spread damage around, and might even have options like fast-moving armor layers or sections that randomly rotate on its outside far faster than the ship can move, to prevent burning a hole through the ship in one spot. Or even large inflatable shield bubbles you can fire out between it and the enemy as expendable physical barriers. Things like this are why we aren't trying to get too specific about what the ranges and scales are, but big ships don't really need fast thought, just good thought. While at the same time they probably have tons of lower layers of brains internally that are dumb and fast, again subminds. It is arbitrary whether or not any of these happen to be human. Again, we could have cyborgs or uploaded minds on hand, or AI that were raised from birth as androids by human parents, or whatever. Speed is critical at lower levels, brains at higher levels, and you're presumably at least building your captain, commodore, and admiral AIs be savvy about deception and manipulation, which means you really don't want to be treating them like slaves or leaving them any reason to seek loopholes in their service obligations. Conscripts make good cannon fodder, possibly literally in that some ships might have cannon shells with smart munitions in them, but you want willing volunteers for anyone who is in anything like command positions, and your ability to manipulate and brainwash them is going to be limited by how clever you want them to be, since spotting and getting around such deception is exactly the trait your strategist needs to have to outfox enemies. In the end, your fleet is only as good as its commanders, and while having super-intelligent strategists is handy for winning conflicts, it is mostly handy for letting them win conflicts, which would include conflicts with you if they decide they would like a promotion to Supreme Commander. Again, it ultimately all comes down to engagement times. And in a surprise attack by some freighter that parks in your dockyard and turns out to be full of automated drones, they might be able to demolish your local defenses and maybe even everything in that hemisphere before you could react properly, which is why it's nice to have a lot of ground-based defenses that remain tucked into bunkers waiting for orders to deploy. That's probably a bit optimistic about such a sneak attack, but it is an example of a conflict occurring in mere seconds, potentially even milliseconds. On the other end of things, a fleet traveling in-system to attack a planet at even near light speeds will likely be detected months, if not years in advance, and be forced to slow not just for the purpose of invading a planet, but to avoid cataclysmic collisions as early system defenses start just deploying millimeter-sized debris scattered in your path and lethally powered by your own kinetic energy. As we discussed in Rebel space colonies, even a fleet planning to invade through interstellar space has a rough time attacking a small colony planet, since they have probably had decades to grow and prepare since doing whatever set you off to attack the rebels. They know your general direction, though thankfully, for the invader anyway, space really is huge, so that doesn't let them place a massive and unassailable minefield the entire way. Plus, dealing with high-speed space garbage is a thing most interstellar ships probably are designed to handle well to begin with. Of course, if your ship collision systems are designed to handle space junk moving 10% of light speed because that's your top speed, then enemy flak coming at twice that speed relative to you might be a serious problem, and you have to slow to a safer speed you can handle, which, given the timelines, might give your enemy entire additional months to prepare and build defenses. And they are manufacturing whole armies and fleets while you approach, so you probably need your fleet to have manufacturing capability too. Ironically, time in transit gives you lots of time to manufacture war gear or breed up soldiers and train them, and that same way, even a purely civilian colonization fleet can turn into a battle fleet very quickly on interstellar timelines. As we like to say on the show, there's no such thing as an unarmed spaceship, and that isn't just referring to the sheer energy the ship has to run weapons, or run into things itself. Interestingly, in this same way, and very swords to plowshares, a battle fleet might also need to turn into a colonization fleet, stopping in a system's outlying regions on some icy dwarf and mining it for materials to fuel its own aggressive growth and serve as a beachhead for reinforcements to not just follow behind, but to make many of those reinforcements themselves. And this might take centuries to unfold, which might be okay if you have life extension, digital crews, or can keep a lot of them on ice. You might even have generation ships on patrols where the crew breed up its own replacements on century-long voyages between patrol nodes. Battle fleets might be engaging in cat-and-mouse conflicts with rivals over many light years and centuries, while at the same time they might be engaging in actual battles that lasted mere milliseconds too, and every scale in between. As we saw today, there is a great deal of variation that given technologies and scales might put into fleet design and tactics. Much is uncertain about what that will look like, but that's nothing new, as nothing is ever certain in war. Not even the weapons and ships you'll fight that war with. Today we discussed how battle fleets might use command hierarchies to handle the need for speedy communications and decisions over long light-lag distances, and even how AI might need to be structured for speed over intelligence. This also applies to truly enormous minds, which might need subminds or regional personalities to handle thinking. In this month's Nebula exclusive, Jupiter Brains and Megaminds, we're going to explore the idea of enormous minds, computerized or not, and just how big they can go, to planet scale and beyond, and how this restructures their mental architecture. That's out now on Nebula, where you can see all our episodes early and ad-free, along with exclusive and bonus content from myself and many other creators, like our monthly Nebula exclusive episodes. You can join now for about $2.50 a month, about the price of the drink or snack you've been enjoying during the episode. We also now have lifetime memberships available and gift cards that let you share Nebula with friends and family. When you sign up at my link, go.nebula.tv/IsaacArthur, and use my code, IsaacArthur, you not only get access to all the great stuff Nebula offers, like Jupiter Brains and Megaminds, you also be directly supporting this show. And again, for those of you who want to share everything Nebula has to offer with your family and friends, Nebula is now offering gift cards. Use the link gift.nebula.tv/IsaacArthur to give a year of Nebula to a friend for just $30. One fleet scenario we stayed away from in today's discussion, even more than fast and light travel, was time travel tactics. And this weekend, on August 25th, 2024, we'll examine the idea of retrocausality and how events could precede their causes under known science and theory. Then we'll finish August up by journeying to the Gardens of the Moon to explore a period of early lunar settlement. Then we'll jump into September for more space fleet discussion as we look at stellar nomads, civilizations that roam the stars in immense armadas. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show by becoming a member here on YouTube or Patreon, or check out other ways to help at isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content like Jupiter Brains and Megaminds at go.nebula.tv/isaacarthur. As always, thanks for watching, and have a great week.